Something.
Okay, you didn't know Kevin was doing it.
I didn't either, but
Are we
I
good?
thought.
Yeah, you're all good.
Already prepared to do.
Thank you, Dan.
Yep.
All right. Good afternoon. Thanks, Stephanie.
You're welcome.
Good afternoon, everyone. Welcome to our latest and greatest seminar. Today we have a familiar face with us. Well, familiar to some of us at least. I think most of us probably know you. But Dr. Dan Leathers, who is an emeritus faculty of our department, was the state climatologist for 25 years. He, of course, founded and directed for a long time the DEOS network and the Center for Environmental Monitoring and Analysis, which now is mine. He's handed those duties over to me, and
Thankfully.
anyway, but anyway, he's going to talk today about a little bit about some of the history of our department and then tie it into some of the new work that's going on. So, Dan, boy,
Thank you. Let me see. And I better not play too much here, but maybe I can. It should be okay if I hit okay here and get rid of that line. I think so. Oh, wait, I went the wrong place, so. All right.
is it on the mouse?
Yeah. I think as long as I can see, I can't see it together right now. Okay. I got it.
Almost. There you go.
Doesn't wanna, okay.
Oh, well.
We'll leave it up. I'm gonna guess. I'm gonna get it later. So I hope everybody's comfortable. If it takes me a month or so. Can you guys see? Oh,
I think it's not.
okay. All right, well, we'll just go ahead then. So anyways, thank you for the introduction and thanks for being invited back. I actually kind of ratted out in the department last semester. I was supposed to give a talk when the theme was the history of the department. And I was scheduled and I planned to do it, but some things intervened. I had a broken leg at the end of summer that then needed surgery. And so I wasn't terribly mobile at the end of the semester last year. So I appreciate having the second chance to come and do this presentation. And the presentation I want to do today does go back a little bit to the history of the department. Okay, so I want this to be I want it to go back and look to see how the history of the department is still informing a lot of what we do in SEMA and DEOS, et cetera. So that's kind of the idea here. And before I forget, you might notice that I had Kevin's name outlined because I knew I'd go to the next slide and not acknowledge my co-author on this. And Kevin, any mistakes that are made in this talk are me. Anything that's good is Kevin's probably, okay? So Kevin actually went at the AMS meeting and gave a talk on the water tracker, which I'm going to be talking about today. And I unabashedly took like 6 or 7 of his slides, modified them a little bit, and they're in this talk. So, and Kevin knows this stuff as well as I do. So if I pass out during this, Kevin can come up and just take it over without any acknowledgement. So I also wanted to acknowledge other people that have worked on this project. Be unfair to not. And that includes Stephanie Baxter and Changming Ye, who's over at DGS. And then Matt Shatley, Chris Hughes, Micah Schlett from SEMA. All these people have been working on this, and you'll see this is a long-term project that's been going on for 3 or 4 years. And Bob Scarborough, I would be remiss if I didn't mention him from DENREC, who's helped with funding, but also helped with a lot of the input into this project. And because I think we should never forget this, I also want to thank Dave Huntley, who's here today, because without the data coming in every day and having those stations working and us being able to get the data, this tool wouldn't be possible. So I also want to mention that.
Just can I point out one thing, Dan?
Yes, what did I do?
Chris, Micah, Bob, and myself are all alumni of this department.
I should have mentioned that as well. Yeah. So there's a lot of connections here. So this is the first thing that I think a lot of people would ask. I know if I gave this talk on the Great Plains of the US or the Western United States, they'd laugh me out of the room. And the reason is why would we worry about water quantity in Delaware? Okay. This is a graph that just shows the total annual precipitation in inches going back to 1895 up through 2025. And you guys answer me, I'm interactive. So why do you think we have to worry about water quantity in Delaware? I mean, we have, if you look at the last 30-year time period, we average 46 inches of precip a year in the state. That's almost 4 feet, right? So why do we worry about water? This is just like being back in the classroom 2 years ago, you know? Blank slate from everybody.
Timing.
It's the timing, but it's also the variability. And if you take a look, for instance, look at this time series. If you go back to 1930, it was the year that we had the least rainfall in Delaware. We had 27 inches. Fast forward ahead 18 years, and in 1948, we had 60 inches of precip. That's a difference of 33 inches of precip between those 2 years. Okay, so huge interannual variability. And in fact, you can really see that interannual variability starting in about the 1970s. Look at that. You have these peak years, usually followed by a couple that are near normal or below normal, then another peak year. Just huge amount of variability from one year to the next. But there's even more variability within the year. Not only do we have interannual variability, but we have a lot of intraannual variability in precipitation. This just shows 2025. February through July of 2025, 5 of those first 6 months had above normal precipitation. And then we hit the skids again. And the last 5 months from August through December, we had below normal precipitation. And if you look at January and February of this year, we're near normal. So no big precip, amounts that have really come through. In fact, yesterday was one of our larger precip amounts in the last several weeks. So anyways, more about that later. So long story short is Delaware has its share of drought and flooding because of this huge variability in precipitation. The flooding is usually ephemeral. It's an event that takes place relatively quickly, comes on quickly, goes away quickly. We're not going to talk much about flooding. That's a whole different conversation. But today, instead, we're going to look at drought, which is often thought of as a long-term climate disaster. Okay, maybe a lot like this talk. It's just something that's a disaster from the start, continuing on through. And remember that drought can take a long time to develop, or it can take a short time. And it also can last a very long time. It's not necessarily ephemeral like flooding is. Now, worrying about the quantity of water is nothing new to our area. And again, you might think, well, why does the mid-Atlantic area of the United States need to worry about water quantity? Well, we can go all the way back to 1570. And this was something that was written that I didn't know about until I researched this a little bit. Father Juan Bautista de Segura wrote back in 1570, before there was English settlers on the east coast of the United States. He wrote about 6 years of maize shortages and famine in the Chesapeake Bay region by talking to the Native Americans that were here. About 40 years later, Jamestown had been set up. If you look at the historical accounts from Jamestown and you look at tree ring data, those two together confirm that there was a 7-year drought that coincided with very high mortality of the early settlers in Jamestown. So this just goes to show that this is a problem that's been around a long time. It's nothing that's new. It's something that is still an issue for us. And that's where we're going to enter the laboratory of climatology. Okay. Now, a lot of you probably don't know what the laboratory of climatology is. I have to stay this close with my clicker. But before we talk about the laboratory of climatology, I'm going to give a quiz. All right. So this is going to be a little quiz for faculty, staff, and students. And all I want you to do is name who these people are and why they're famous. Everybody that's associated with GSS should be able to get 100 on this quiz. Right. So first off, who's this person? Oh, good heavens. In class, I used to bang my head on the wall when I got answers like this. So if you don't want me to bang my head on the wall, it's C.W. Thornthwaite, okay? The famous C.W. Thornthwaite. You'll see why he's important to us in just a minute. And I swear to goodness, if you guys don't get this immediately, you are all going to be haunted tonight. Who's this guy? John Russell Mather, okay? And why are these two famous? If you had to pick something.
I know, but I'll let somebody else answer.
Okay, we'll get to that. That's what we'll get to next, is why these two are famous. But what we're really interested in these two for is because of their water budget approach to looking at climate, which is simple, but one of the most elegant and really amazing things, I think, that has come out of climatology over the last 100 years. So a little bit about the laboratory of climatology, because I want to connect up again what we're doing in SEMA with what was going on 80 years ago, literally 80 years ago. So if you go back and you take a look at the Laboratory of Climatology, it was founded by Thornthwaite back in 1946. It was originally in Seabrook, New Jersey, which is just across the bridge and really across the Delaware Bay. It was later moved to Centerton, New Jersey. Thornthwaite established the lab, as it says here, as a place where he could work as a consultant with Seabrook Farms. And does anybody know, I was going to check this, I never did this morning, is Seabrook Farms still a
Yes,
agricultural producer? I think so.
so big into vegetable production.
In the eastern US?
Oh, in southern South Jersey.
Okay, right, yeah.
Little thing.
Yeah, so he was working for them after he left the government. I won't go through the whole Thornthwaite history with you. You've probably heard that before. And the lab was originally associated with Johns Hopkins University and then Drexel University. But as you'll see at the bottom here, it then became associated very much with the University of Delaware. And the significance of the lab of climatology is it became really a major research laboratory for really the world, worldwide, looking at things like microclimate and especially evapotranspiration, and later on the water budget. Now, the facility remained in Centerton. Actually, Thornthwaite died in 1963. Russ Mather took over. He didn't like doing that, basically. He was not an administrator. He wanted to do research. He wanted to do some other things. He was offered a full-time job at the University of Delaware. He took the job as University of Delaware, subsequently became the chair of the department that would eventually become GSS, which you're sitting in right now. And so we have, long story short, we have a lot of connections to the laboratory of climatology, the direct heredity coming from that laboratory of climatology to climate here in our department. Now, just remember, as we go through this, that GSS has very close ties to the laboratory of climatology. The Thornthwaite-Mather water budget, here's some milestones. It was founded in 1946. Just a really seminal work by C.W. Thornthwaite in 1948, where he looked at the climates across the globe, no longer based on temperature or just precipitation, but he looked at them based on the water budget. What is the difference between the precipitation coming in and the evapotranspiration going out? And you'll see in just a minute, so again, very simple but elegant. And then I also want to just point out that the mid-1950s, I'm going to show you, the last slide is a really horribly boring slide. I'm going to show you the list of publications from Russ Mather that he did on the water budget back in the mid-1950s. Amazing publications, right? That are still being used today. Now, these pictures, just to show you, this I think is Russ Mather. I couldn't verify that, but I'm pretty sure that's Russ back in the mid-1950s. They were actually looking at dispersion and had these little things that they would shoot off with various types of gases and then look at how dispersion was taking place. Here you can see a boat outfitted with microclimate equipment. I'm sure they're measuring the evapotranspiration over the water body there. But I love this one because of something I found while I was researching for this talk. Thornthwaite actually published in the mid-1950s a little paper on what was going on at Seabrook Farms and what was going on at the lab of climatology. And they were actually taking wastewater and putting it through spray irrigation, which we hear about all the time now, but they were one of the first people that did it. But just think about this for a minute and look at this. I had to laugh when I read this. This is what Thornthwaite said about their spray irrigation plot. Through the season, the rate of application at that plot averaged nearly 50 inches a week. Now think about that for a minute. 50 inches a week. And as he said then, since the rainiest areas of the world, the rainiest rainforests only receive about 50 inches of precip a month. While they were doing these experiments, that Seabrook Farms forested area, by all odds, was the rainiest rainforest in the world. Okay? So they were doing some really special and very interesting things at the Laboratory of Climatology. This was not a, 1 or 2 person operation that they were doing some really groundbreaking things and some really interesting things. I would just like to know that was wastewater from some not nice places. I'm sure that most of that 50 inches a week just ran off to somewhere, but at any rate, he didn't say anything about that in the paper he wrote. So what's the water budget look like? Well, the elegance of the water budget, boy, I sound like a missionary or something for the water budget today, but the elegance of the water budget is really its simplicity. All you need climate inputs to get at the water budget is monthly precipitation and monthly temperature. Monthly precipitation is just an observation, so is temperature, but then you take that temperature for the month, you put it together with the location of the station, which gives you kind of the day length. And this is what Thornthwaite-Mather came up with. They came up with a formula that if you take that data, it can estimate the amount of evapotranspiration.
Wow.
What was that? It's not on. Well, it is on, but it doesn't show that it's connected somehow.
Okay, they say they can hear you now.
Okay,
Yep.
well, then.
Can you hear now? Yep, they said they can hear now.
Can you all hear me good? Good, boy, that
Yep.
shows. my-
Yes, they said they can hear you. Yep, they can hear you.
Okay. We'll take that, check to see. Now, I want to know whether or not they can actually make a retired guy pay for the Zoom. I mean, the hours.
Okay. All right, sorry for the interruption.
So, no, I apologize.
You're welcome.
I walked by like this and just barely rushed it. I mean, yeah. So back to the water budget. So how does this work? Well, if you take a look at those first 5 months of the year, you'll see on the water budget calculation sheet that you have more precipitation coming in than evapotranspiration going out. You'll notice the soil moisture gets to 150 millimeters. That's the capacity of the soil. But then when you get to June, notice that you have actually less precipitation than evapotranspiration, which means that you've got a water deficit. Where's that water for the evaporation going to come from? It's going to come out of the soils. And so you'll notice in that line there that at the start of the month, you had a field capacity as far as the soil moisture is concerned. By the end of the month, that'll be down a little bit. Okay. And then in this particular case, this example, you're back to positive water budget numbers the whole time. It just goes back to field capacity and goes on. But this again is just really a very simple system, but amazing. And it really gives you a lot of applications. And so these are just a few of the applications of the climatic water budget that I wanted to point out. You might wonder why some are red and some are in black. Well, the red ones here are just the ones that we've really used in SEMA to help build some of our products. And so Kevin pretty much himself, with a little bit of help from others, but built the Delaware irrigation management system. What does that use? Well, that uses the application of the climatic water budget to estimate soil moisture availability for crops, determining irrigation needs. We do a lot in SEMA and the State Climate Office and identifying drought conditions for the state. That all comes from the climatic water budget. And really, the big thing here is assessing watershed water availability is what we're doing in the water tracker tool that we built. So all these connections are going back to the 1940s and 1950s with the laboratory of climatology that is, of course, again, very much connected to us. Now, we're going to jump ahead 60, 70 years to the development of the water tracker. And just to show you, so this is a high quality graphic here, but I thought this would work. The Delaware water tracker tool, we talked about for how many years, Kevin, before we did it? Probably 8, 10 years, literally. It was being talked about regularly with the people at DNREC, DGS, SEMA, all saying, boy, we really need to get a handle on how much water is available in the watersheds across the state. How can we do that? And as you can see there, it wasn't until 2023 that DNREC committed their first funds for a multi-year project to build this tool. But what I wanted to make sure to say was all the time that these discussions were going on, the ghosts of Thornthwaite-Mather were in the room. Because the way to look at this is with a water budget approach. And so, you know, they were always there. Sometimes Russ was hanging on the wall in the conference room there. And but it's just amazing again that what they did all that time ago is still being used today. Oh, great. Now this isn't working. That's right. I can do this. So the water tracker is a tool that's taken a long time to develop. And I just wanted to point out that a lot of times tools that you want to develop for something like the state government, which is what we were doing here, take a little bit of time to put together. And so, as I've already mentioned, the first funding was in February of 2023. That funding was to just look at some watersheds in Kent and Sussex counties in Delaware and try to prove to ourselves and do a prototype, is this possible? The second phase of funding was a year later in 2024. There we said, okay, it is possible, but how are we going to put this huge amount of data together? We're doing this model really on a daily basis. How do you put all that data together? What data do we need? That was a whole year's project in and of itself. And then last year, we got the funding to actually build the system, put the tool online where it should go public here in early 2026. Okay, in fact, maybe within the next few weeks, right, Kevin? And right now, we've also started a new project funded this February that goes one step further, and we're trying to simulate, as it says there, groundwater availability in the superficial aquifer across Delaware. And the way we're doing that is we want people to be able to come in and say, I want to change irrigation, I want to change the climate, and I want to change land use land cover. And then put that in and be able to know what's going to happen to the superficial aquifer, the amount of water available to them, if those changes are actually made. So that's what we're working on right now, but still we're working on the tool itself. Now, just quickly, I'm going to go through these next few slides quite quickly. How is drought monitored in Delaware? While it's a complicated process, anytime you work with the state or the federal government, it becomes complicated. So it's a complicated process. It's overseen, drought is really overseen by the DNREC secretary through the Division of Water, which is one of the divisions of DNREC. And if you don't know what DNREC is, that's our Department of Natural Resources and Environmental Control. Okay, weird name, but it's essentially our environmental agency in the state. There are two main committees that make a lot of decisions about water quantity. One of them is the Water Supply Coordinating Council. It's there to do exactly what it says, coordinate water supply across the state. Okay, it meets regularly, 4 times a year generally, as I remember. And then we have the Governor's Drought Advisory Committee, but that only convenes as needed. If there is a drought and it looks like things are getting bad, then the governor can convene this committee, and there's regular meetings, usually weekly, and the situation's watched very closely. Just to give you a little flavor, our Delaware Climate Office, which I hope most of you know is within the department, leads the Water Supply Coordinating Council Drought Monitoring Subcommittee. When things get bad, it's going to lead that committee, and it makes recommendations to the U.S. Drought Monitor regularly, and it co-monitors really the situation across the state with DGS. And I don't want to leave DGS out of this because they do amazing work themselves. That's why we're working on them with them with this tool. They're more interested in stream flow, groundwater, things like chloride concentrations in the Delaware River. Whereas SEMA, you can see we go together nicely. We're more interested in the temperature and precip outlooks, drought indices, surface water budgets, soil moisture, things like that. I like to think that as DGS kind of interested in streams and what's under the ground, and we're interested in what's in the soils and up into the atmosphere. But together, I think we do a pretty good job of monitoring. Why, again, did the state want this water tracker, this ability to track the water quantity? Well, drought has been a long-term issue in Delaware, as we've already seen. The other big thing is for many, many years, the Water Supply Coordinating Council of the state was really only concerned, yes, I can say this, although it's going to be on YouTube, so was mainly concerned, maybe I should put it that way, with making sure that there was enough water for the high population density in the northern part of the state. So a lot of the efforts of the Water Supply Coordinating Council went into making sure that there was plenty of water for drinking water and other needs in the northern part of the state. But over the last several years, as Kent and Sussex County has grown, as there's been a big increase in the amount of irrigation taking place, big increase in number of people living there, putting in domestic wells. They really wanted to expand the focus across the entire state. And so that was another big reason that they wanted this water tracker. And it's just true that groundwater is extremely important to agriculture and drinking water in rural areas. And Kevin, you said what? It's about 75% of the people in the state depend on groundwater?
About 2/3, 3/4.
For water. So we better know how much water there is, because most of the people in the state depend on that water. And the other thing is we're starting to get a little bit of a better grip on this, but there was a very limited real-time groundwater well network available. There just wasn't that many, especially in the superficial aquifers, to monitor that real time. Wells are expensive to drill, they're expensive to upkeep, etc. Okay. So we were tasked with building an operational system. And this is always the problem, I try to think how to best say this. It's kind of easy sometimes to build a system that doesn't have to be operational and up and running 24/7, every day of the year. But we were tasked with, us and DGS, coming up with a way to build an operational system. And it's at the HUC 12 hydrologic scale, so every one of the little polygons on that map of Delaware you see there is a HUC 12 watershed. They wanted it at that regional scale. They wanted to be able to look at those HUC 12 watersheds and say, what are the water conditions in that watershed right now? They wanted us to focus on groundwater level in the superficial aquifer. But not just that, they also want to know how streams are doing. They want to know what soil moisture is like, et cetera. But the way they wanted this presented was how unusual is the situation. So you can see right there where it says water level, they wanted it broken up into kind of categories. Is this particular watershed very wet? Is it wet? Is it normal for this time of year in this state? Is it dry? Is it very dry? Okay, that was what they really wanted. And that's what we had to build this towards. Our biggest problem with this whole project is the limited well data. We're trying to predict something that there's only 9 or 10 long-term superficial wells that have data at least 10 years or longer for the state. So our biggest problem here was that we were really short on the well data. So we had to come up with a way to grapple with that, really. And the way we did that was thanks to Thornthwaite and Mather and DIOS. We said, well, what really drives the water in the superficial aquifer? P minus ET. Right? There's more precip coming in and evapotranspiration going out. Where's that water? It gets down into superficial aquifer. If there's more evapotranspiration coming out than precip going in, you're going to start using up that water in the superficial aquifer. So we went back and said, okay, let's take our DIOS data, thanks to Dave, and we have 15 years at all of these stations that you see across the map of Delaware there. And we said, let's go ahead and look at the precipitation minus evapotranspiration climatology for the state and regionalize based on that climate. So how does P minus ET change across the state? We did cluster analysis. I won't go into all the statistics we went through, et cetera, but we did cluster analysis and came up with different regions across the state that act together as far as P minus ET goes. So think of it this way. What we were trying to do is come up with regions that had the same, essentially, bank account, money either going in or out, right? And we could say, well, these all are very much the same. We did it for the cool season and the warm season because the warm season is very different as far as convective precipitation and so on goes. It's kind of the way we broke it down. And as it says here, we identified 3 regions for the warm season, 2 regions for the cool season. You can see here the 3 regions during the warm season, mostly Newcastle and Kent County, and then Sussex County actually broken up into 2 regions. And you can see those with the colors on the map on the right-hand side there. And then if you take a look at the cool season, it's very simple, just 2 regions across the state that behave similarly with P minus ET, one covering Kent and Newcastle County, the other Sussex County. But what did this do? Well, this allowed us, it's the bottom sentence there that's most important. This gave us 5 statistical models we had to develop with our limited amount of groundwater data, compared to having developed individual models for each of the watersheds, where we had to develop 100 models, and we don't have the data to develop them most of those watersheds. So regionalizing based on Thornthwaite-Mather really helped us out hugely and made really the project possible. So basically, what did we do? Just very quickly here, we used stepwise linear regression, and we said, okay, we want to know how much water is in the superficial aquifer. So we've got this well data, 2 or 3 wells in each of those regions. We aggregated that well data. We said, okay, that's our well data. That's depth to groundwater. Now what we want to do is see if we can predict that with some of these more meteorological variables, drought indices, et cetera. You can see here that we use precip, temperature, evapotranspiration, and precipitation minus evapotranspiration from our DIOS stations. We use stream flow from the USGS, and we use drought indices from NOAA. And keep in mind though, and this is something that I don't want you to forget, see how those drought indices are great. What are those drought indices all based on? Thornthwaite-Mather. They're based on Palmer. And by the way, Palmer goes back to Thornthwaite-Mather. Palmer was on the ag campus here at the University of Delaware when he developed most of the Palmer drought indices. So again, long history of this for the university and for our department. So we just did the regression models, and this is what we ended up getting, and I don't want to spend a lot of time again. But basically, for instance, if you take a look at Warren Region 2, that's that pink that covers Newcastle and Kent County over there. When we did the regression, the stepwise linear regression, we found that the important variables going in that would predict the amount of groundwater were cluster 2, P minus ET, Thornthwaite-Mather, the PDSI, which is the Palmer Drought Severity Index for Division 1 across Delaware. That's the northern part of the state. Guess what PDSI is based on? Thornthwaite-Mather, okay? And then 2 USGS stream gauges. And using just those 4 variables, we can predict with an adjusted R squared of 0.72, 72% of the variation, we can get the daily well levels in that region. Okay? So it did amazingly well. We didn't think it would do this well. If we got an R squared of 0.5, we thought we were going to be, we were going to be very happy. But as you can see, it depends on which region and which time of the year. But we're doing a pretty good job in all the regions. And this just shows you how close it is. This is region 2, the warm season, the one that I just talked about, has an R squared of 0.72, mostly Newcastle and Kent County. The red here is what our model predicts for the superficial aquifer. The blue is the observations. I'd say that does a pretty good job. Okay. Over there, the other side, on the right-hand side, is cool season region 2, which is our worst matchup between what's predicted and the observations. And you can see there's a lot more variability here. We miss out on some big spikes that take place, but in general, we're still getting the overall trend from one time of the year to another correct even across that region. Now, these are kind of ugly graphs, and Kevin made these, but he did a great job because I would have done the exact same way. But I didn't want you to be insulted. I said they were kind of ugly, but they're just really showing with orange, which is one of the wells that we use in our calculations. We just went back and said, okay, how well are we doing with individual wells? The blue is our model projection. You can see they're pretty much on top of each other again. And this is actually looking at it by category. I'm going to cover that one up real fast and just show you this, which we were really happy about. Is if you go back and look and you break it up into the categories. So you say, okay, would the category that our prediction would be, would it be saying very wet? Would it be saying wet or normal? And then compare that to what the observations would be saying. 90% of the days were within one category of the correct value for those wells in that region. There's only about 8% of the days over the course of the year that were 2 categories away. So we're doing we think we're doing a pretty good job with this as far as getting these categories right for the individual watersheds across the state. We also use some unused well data because you might say it's not really fair using the data that you use to essentially calibrate your model. So we went back and said, okay, here's a new well that was put in. Let's see how well it matches up with what we predict. And again, the projection was very good. So we feel fairly comfortable that it's doing an okay job. So what do you get then with the Delaware water tracker? And the tool is done. I'm going to give you the URL for it in a minute. I don't have time and you guys don't want to see me take the time to demo the tool, but I'll give you the URL if you want to go on and play around with it, please do. And let us know, let Kevin or I know if you find any big problems, because it's a work in progress and it will be for probably several years to come. But what do you get with the Delaware water tracker? You get a nice interface where you can look at a map of all the Huck 12 watersheds across the state that tells you whether they're dry, very dry, wet, whatever. You can then click over here on the watershed that you want. I actually clicked on the Upper White Clay watershed because that's where we are here in Newark. And then you get the chance to look at the individual values. You can look at time series, you can pick the length of the time series, etc. This is what the folks from the state wanted to see. And I just want to show you one quick example here. But before I do that, I want to ask you a quick question. What do you think it's like out there as far as superficial aquifer goes in northern Newcastle County? Is it dry? Is it wet? What do you think?
Dryer.
Drier? Okay. Well, actually, I've already shown you here. But if you take a look, not only is it drier, but it's very dry. And there's reasons for this. I want to show you how you can see this in the water tracker. So I was looking at the White Clay Creek watershed in Newark here. This is the map from April 1st, when I was preparing this talk a few days ago. This was the last time I pulled off the map. But on April 1st, 2026, water level was estimated at very dry. So let's see if that makes sense and if there's anything to back that up. But what I also want to show you here that's going to just phase in over this map, this shows you the water level, but I also wanted to look at 90-day precipitation of evapotranspiration across that region to see what it looks like. And this is something that you can do in the water tracker tool. So let me just hit that and oops, I went past. So this is the 90-day precipitation. And what do you see for the 90-day precipitation for us? It's been dry. Okay, so think P minus ET now. So precipitation is down. Well, what's evapotranspiration like? Well, we can show you that too. Evapotranspiration in our region right now is normal to low, somewhere in there. It hasn't been over that 90 days, hasn't been real high, hasn't been real low, it's been kind of normal. So we have less precip coming in, normal amount of evapotranspiration occurring. I could tell you a little bit of something there that maybe it's getting a little dry, but there's more that you can get here. Instead of just looking at those two very simple things, we can go back. And here what I've done is I've looked at a year going back from April 1st at what the water level's been in northern Newcastle County. It's been very dry or dry that whole time, okay? And I think there's a good reason for that I'll show you here in just a minute. But let's just go ahead and overlay here with the water level, what the precip and what the evapotranspiration looks like. And here's the precipitation. And note over here, these blue colors are periods when it's been very wet over a 30-day period. The red colors and yellows are when it's been dry or very dry. And you'll notice that about a year ago in the spring and early summer, we actually hit some pretty wet times. And some of you may remember that we had some big convective storms. It felt fairly wet here. But then look what happens on September 1st of 2025. It gets very dry, and this rest of this time up until the present, we never really go much above the 50th percentile in the amount of precip that's falling in northern Newcastle County. So it has stayed dry or very dry as far as precip goes over those last, 6-7 months. It's been quite dry again. And if you look at the evapotranspiration, back here when we were getting a lot of rain, there was actually smaller amounts of evapotranspiration. The very wet for evapotranspiration means not much evapotranspiration. The very dry means a lot. But look what happens again as you get out into the fall. The evapotranspiration pops up. You actually get some 30-day periods that we saw the highest evapotranspiration in the last 15 years. So we have lack of precipitation coming in. We have pretty good evapotranspiration going out. And if you go back to Thornthwaite-Mather, you have several months with low precip, moderate evapotranspiration, it's going to result in a reduction in the superficial aquifer, or excuse me, the superficial aquifer. Now, one more slide to show you that, because you might say, and I would probably ask this, so I'm trying to sort of help myself to not have a question here. Well, you got all this precip coming in early. Why didn't that just build the water back up? And why is it that, we've been dry this whole entire time? Well, I can show you that again by using the water tracker to just show you here the precipitation going back now about 1.5 years. And so out here is April 1st of 2026. Back here is August of 2024. I don't know how many of you remember, but Kevin and I do, because we were on calls constantly. We had the driest fall pretty much ever at the end of 2024 here in northern Newcastle County. Wilmington had its least amount of precipitation. How many days did it go without? 38 days without measurable precipitation. Incredibly dry. And so that extreme dry period right here really got this whole thing started. Got us into the point where soil moisture was dry, the aquifer had not filled up. And even though we got some of this precipitation here at the beginning of 2025, as soon as things started to look good, and this is the truth, the state had declared a drought watch. Right, Kevin? Tell me if I'm wrong.
It was in October, November of 2024.
Right, yeah. And but we raised the drought watch right about here.
Yeah, there we go.
So it's when we stopped the drought watch, it immediately stopped raining again. Okay, so that's often what happens. So we stopped the drought watch, and then we've hit this string now of months since September of 2025, where we've had much below normal precipitation. That's why we've been in this now for about a year and a half, and frankly, we haven't had any big rains, and the snow that we had helped a little bit. We had a little bit over an inch of water in one of those snowstorms, but we need some water. We really do. It's going into the dry or into the warm season, we could end up with some problems. And in case you don't believe any of this, so I had to throw in something independent. What did I look at? So I went and looked at on April 4th at the stream flow conditions from USGS and looked at what the stream flow is like in northern Newcastle County, much below normal. Why is that? Because the superficial aquifer's down and there's less base flow. And there's no precip falling, or essentially no precip and runoff of the rain. So it works amazingly. But who do we really have to thank for this? Well, not anything that we've really done, but what we have to thank for this is Thornthwaite-Mather actually works. It's been around for 80 years, but it still informs all kinds of work across the country. So in summary then, using readily available climate and hydrologic data sets, and I shouldn't, we do say readily available here, but we're assuming we have DOs. If we didn't have DOs, this wouldn't be possible for the state. But with those data sets, we successfully created statistical models that we think can predict groundwater level to a sufficient accuracy. And notice Kevin had this down and I liked it and kept it still to be decided, because Kevin might go to the next water supply coordinating council. I love being retired, by the way, so I get to work on this and I don't have to deal with any of the headaches with the state. So it works out just wonderfully. But he might go to the next water supply coordinating council and they might say, we want this more accurate, or we want to change this, or we want to change that. But we think that we're just about there. And the main thing is this entire approach is based on Thornthwaite-Mather concepts. They run all the way through the heart of this department. Okay. The regionalization approach was just using P-ET. It eliminated our need to come up with individual watershed models. We're able to only have 5, much easier for computation and trying to deal with a system like this. And the main thing is Delaware now has an operational tool that provides relative values of groundwater, precipitation, evapotranspiration since 2010 at the daily time scale for each of the HUC 12 regions. And let me just leave you with this because I'm done. Better make sure I'm done. Yes, I am done except for one slide. This is all applied climatology. Okay, none of this is hard. And I want to be careful how I say this, but the water budget is not groundbreaking stuff anymore. But the applications of the water budget just go on and on. You see it everywhere across the country and of all kinds of different tools. And it's that idea of taking what might not be the coolest, newest thing, but actually using it to solve practical problems that I think is really important. And that, is something that we should try to do more often. We're hoping for a public launch in the next couple of weeks. And this is the last slide. And I just wanted to show you this. This is just a partial list of papers written on the water budget by Russ Madison. And, I'm assuming that I'm not ever going to get haunted by Russ again after I've given him so much credit today. So, but he and Thornthwaite worked on together. Some of these, you know, if you went back and looked at the number of citations in a lot of these papers, they're thousands upon thousands. Okay, very simple, but extremely helpful. And these two down here in red, I just wanted to point out, are books. He did a whole book on the climatic water budget and environmental analysis. And also he did a book really on applied climatology. So with that, I think that I'm pretty well done. So I apologize if I've been too much of a missionary again for the water budget and Thornthwaite-Mather, but I think it's really important that we remember where a lot of this came from. And that's still there to use in dissertations, research, it's all out there. So don't neglect it. So thank you.
Yes.
Questions?
So submitted.
Dan, you're right. It was a very good talk. It does fit in nicely with the history, so it's too bad that you broke your leg for a number of reasons, besides not coming last semester.
Right.
But my question is, you did, and I'm just trying to be fair here, but you glossed over the 60-70 year period between the 50s and you jumped up to what you guys were doing.
Mhm.
But having been in the department since 2003, like I know Court and Kenji had one bug, and there were other things that were going on in the department too. Maybe you could just speak briefly about that. A, what bug is, and then B, how does that product or work interface with what you guys need?
Well, WattBug was a way to calculate the climatic water budget anywhere across the world. So you could put in a latitude and longitude and get what the climatic water budget should look like. So in other words, what's the average precip there? What's the average evapotranspiration and where you have a deficit or a surplus? So it's great from a teaching perspective. It's also used by government agencies, we found out, to make decisions about things like where are marshlands or not by looking at the water budget and how much water is there and the time of year. And so that was Court, and Kenji did a lot of work on that. Dave Gates, I think, did a lot of work on that. And part of that was putting together the data sets for the entire globe, the temperature and precip that you could use to calculate the water budget parameters. So again, a huge project. There was also WattBud, which is the water budget that you can use that program to look at the water budget again pretty much anywhere. But it was often used with climate division data for the United States. That was a huge project. There was a lot going on here. I bet you if you go down and look at the dissertations and the master's theses that you would find that at least 25% of them for a good part of the life of this department included things that were water budget related. So huge amount of work here. But what I think amazes me on a regular basis is how much of the water budget is still in a lot of what is available out there online. You don't know it. It doesn't say it's Thornthwaite-Mather water budget, but you look and they're using Palmer. Then you look at Palmer and it's Thornthwaite-Mather, you know, and it's ubiquitous. It's everywhere. And so it's something that I think as a department, we should probably play up because it's it's something that people use constantly and they don't know where it came from for the most part. So I don't know if that answers your question or not, but there was a huge amount of work going on, but that work spread across the country to all kinds of projects that other people are running, and you just don't know that Thornthwaite-Mather at the heart of it.
Right, not WattBug and WattBud was a direct result of the work that Mather and Thornthwaite did before them.
Yeah, exactly.
It all builds a nice continuity. I agree with you, though. The department should do more to have people recognize the origins of that work. Absolutely.
Right, because it's so much a part of drought monitoring, so much a part of people that are worried about water. There's been a lot of things. I sound like a messenger for them. Don't forget that there's been a lot of things that have been added on that have made that much better and have, but at the heart of it, the core of it, it's still Thornthwaite-Mather.
Other questions?
Yeah.
Wonderful talk. It's given useful predictions. I was wondering about the effect of the large scale of wind field. Is it completely steady over the last 70 years? So one of these is the Professor Bruce also shows that the evaporation is to the fourth power of the velocity. So a small change in the wind field can.
Yeah. Well, that's a mean question to ask, because I can't, wind is one of the things we measure, I'm joking about being a mean question, it's a great question. Wind is one of the things that we don't measure very well. I shouldn't say we don't measure it very well, we measure wind speeds okay, but there's not much long-term wind speed data. And when we do measure wind speed, and we're looking at gusts, or how do you calculate the average wind speed, what time period is that over, what instruments are you using, it becomes a mess. So when you go to look for wind data, it's one of the things that there's very few long-term data sets that are people generally trust. But you're absolutely right in that, you know, Thornthwaite-Mather was the water budget, and using the temperature and the day length and latitude was pretty much empirically drawn. Okay, and so you could ask, has the large scale wind field changed? How has precip distribution changed? Are there more big than there used to be, big precip events? And that's all very good questions to ask. It could change that relationship. And as far as I know, I don't think anybody's really ever looked into that too much. I mean, we all know that evapotranspiration is very dependent on winds, it's dependent on solar radiation, it's dependent, you could look at cloud cover and say, how's cloud cover changed? So those are all negatives, if you want to put it that way, built into Thornthwaite-Mather, that, you know, it would be great, anybody's looking for a dissertation, be great to take, what they used.
Long-term trends in evapotranspiration and breaking it down by the inputs. and
Yeah.
components.
It'd be wonderful. You know, that's a whole. You would get a lot of citations with that if you did that, trust me, but excellent question, and it hasn't changed. And probably it should, but nobody's taken that on yet. You know,
Any
there?
Are
questions?
there any questions online? Okay, we have one from Gabriela. Gabriela, can you speak up?
Yes, can you hear me, please? Can you hear me? Oops. Can you hear me now? Are you hearing me? No?
Gabriela, go ahead, ask your question.
Yes, are you hearing me? I'm not so sure you can hear me.
It's not, can she type it in?
Oops. Can you hear me?
Oh, they're saying that she's talking, but we can't hear her.
Yeah, we can't hear her because the app's probably out.
You have to Gabriela, can you type it in the chat?
Yeah,
No.
I'll type it in a minute.
No,
okay?
she can't.
She says, can you hear me? No.
You cannot hear me, right?
I don't know if that's, we hope it all.
I remember one other time I was here and this exact same thing happened, that fell over outside. And it didn't work the rest of the time and it had to be I forget what. Fixed it.
Nancy has a question.
Sure.
Okay, maybe while we wait, go ahead.
Since you mentioned that this is used by government decision making.
Yeah.
So I wondered, was it used like in the data center decisions, and also how do industrial decisions like pollution from and pollution of the water table build into this model?
Well, so I guess my answer to that would be is I don't know that it's been used for data centers. Or anything like that, it very well may have been, I think EPA was using it, wasn't it, to classify marshland or something?
Yeah, basically to determine the WOTUS rule, the waters of the US. They're using it to determine if a area of water was an ephemeral area of water, essentially based off of the water budget. So
Right.
if they saw water, like a waterway with some wetlands, and it was a time of year when the water conditions were greater than the anticipated water budget would be, then they wouldn't use that observation period in their decision-making process. They wanted it to be within a typical time of year. for the classification of those wetlands as either subject to the EPA rule or not subject.
But, yeah, and then just for the other part of that question is, I know of many projects that have looked at placement of industrial centers, groundwater pollution, things like that, that have used parts of the Thornthwaite-Mather certainly as part of the way that they've looked at the problem that was presented to them. And so it has been used very much over the course of the year, not just over the course of the years, not just by government or anything, but also by, any hydrologists out there, engineers, et cetera, have used Thornthwaite-Mather for years to get some of the questions.
All right, the question
Yes.
for you is, do you consider in your estimations temporal and spatial correlations of precipitation and groundwater levels?
Do you say that one more time?
Do you consider in your estimations temporal and spatial correlation of precipitation and
Yes.
groundwater levels?
Yes, well, I guess I can say this, it's completely matched up spatially and temporally, so all the input that goes into the different HUD 12 watersheds come from our DOS data and interpolating to the center of those watersheds. And so, we do as good as we can in making sure that spatially we're getting what really fell in that watershed as far as precip goes, what evapotranspiration has taken place, and everything else is done temporally coherent. It's all done on a daily basis. This model is run every day. You go out, get all this data, rerun the statistical models, and you get your new water level, predictions.
Any other questions online?
Any more questions in the room?
Again, I'm sorry, people online, you have to type the question in the chat.
Any more questions online, please?
No.
Okay.
We'll try this.
Should we just-
To see the model of.
Frankly, what I would like to see happen is for there to be more awareness that of Thornthwaite-Mather and what it's in and what it, there's so many things that are based on Thornthwaite-Mather in one way or the other. I'd like to have better awareness that that's the case. And as Dell and I were talking about, I would really love to see somehow our department get the credit for being in that line, that hereditary line. And it's not like one of those things where, they started it and nothing's been done with it since in our department. Our department's really popularized it, put out a huge amount of publications. We're now building tools with it, et cetera. So there's that constancy from the time it started up till now. And I would love to see GSS and the Department of Geography at the University of Delaware get some credit for some of that. For me, it's more now that I'm retired, it's more of a legacy thing, not my legacy, but the legacy of the department. I think that we should play that up a lot more. And we probably do.
Oh, everybody, thanks, Dan.
Sorry, I broke the owl.
Al